Hello, everybody, and welcome back to the Internet Programming and Internet Computing class, COSC 6341 and 4341. And today in this class, which will be the second week of our class, our Internet Programming and Internet Computing class, I will continue on the topics that we started last week. And I will, in a little while, I will give you an overview of what we will be studying. Now, if you have made it through the first week, you probably will notice that you probably have noticed that we have the class lectures that are these video lectures that are being given by me and recorded as a flash file, and they are incorporated into a website. And I will give you the link to that website, which is from the Adobe Connect website from UHV. And as I mentioned earlier, you could go through the slides. I will put the slides online as well in a separate folder. And all of the materials except for the slides for each course or each class in each week will be uploaded on a learning module for that week. It will contain an introduction to that week's materials. It will include the lectures, which are the flash files here. I will put extra reading materials, which will be either PDF files or web links. And also at the end of each week, we will have a discussion. So when you finish studying for the week, I will appreciate if you participate in the discussion. Usually there are simple questions about what you think about this, what you think about that, what you learn in this section, and so on and so forth. And I would appreciate if you would just spend the time putting a couple of paragraphs. This will essentially help you remember the things that we studied, and also it will help me see how the class is moving along, since this is an online class and I would like to have the connection with the students and the learning processes in our class. A quick note as to how to use these videos. Of course, if you're watching this and you're hearing me talking, you already have started this video. The resolution that was optimum in terms of putting the files online, the file sizes, and of course downloading the files according to the internet speed that you have, would be 800 by 600. That would have made it a little bit more blurry for the videos when you watch it on full screen on the screens that are very high resolution. I have a couple of recommendations for you. One would be to either decrease your screen resolution specifically when you're watching the videos, and the second is that try to have the video lectures with you when you're watching the video, so you can print them off, and if you need to read stuff, you can read them from the lectures. Although I will try to use the magnifying tools that I have here whenever I'm pointing to a specific text that you may need it. I'll try my best to either put it as a caption or a call out on the text, or zoom into that particular location on the screen, and hopefully that will help with this situation. I have tried larger screen resolutions, and the files were so big that even with high-speed access from the university, it was a little difficult to get to them. But please, again, in the discussions and by emails, let me know about the lectures, how they are moving along, and how I'm doing in terms of the clarity of the lectures, so that we will improve our interactions and our learning experiences. Now, today in this class, I'll just go over the rest of introduction to the internet and the web. Last week we saw the World Wide Web was created by Tim Berners-Lee in 1990 and 91 at CERN, which is a European Research Institute for particle physics. And then in MIT in 1994, a group, essentially a conference, was established, WWC, which is World Wide Web Consortium, and they developed the web standards. And now today we will talk about two-tier communication systems through client-server computing, and then we'll talk about three-tier systems, which consist of client processing and data storage tiers. And then I'll talk about client-side programming through JavaScript language. And then I'll talk about the advantage of that, the client-side programming, and disadvantage of the client-side programming, and why we want to move our programming, some of the programming, to the server through active server pages, or ASP. And then Microsoft has developed a very nice server-side technology, or server-side scripting technology called ASP.NET, or the .NET framework. And throughout this semester, we will mainly focus on .NET 4.0, which is the latest framework that Microsoft released. And Microsoft Visual Web Developer 2010 contain all this information and essentially the programming tools that we require and we need to do ASP.NET 4.0 programming. But we'll probably not start ASP or full-fledged ASP programming in a couple of weeks, because some students may have experience with HTML and CSS programming, some may not have. So I will give you an introduction on the two technologies, and so you would just go ahead and study those in the next couple of weeks, and then we start our ASP programming, which is a really nice and interesting aspect of web programming, especially on the server side. Later on today, I will show you about the integrated development environment of Visual Studio for web development. And it is a part of, as I said, Visual Studio. It includes C++, C#, Visual Basic, and Visual Web Developer. We install Visual Web Developer, and as I said, Visual Web Developer includes ASP.NET to develop server pages, and also to it includes a virtual web server that would allow us to test our websites and web pages and web projects that we create. And so I will show you how to install the web developer. We will talk about HTML, and we talked about HTML 1.0, and then the evolution of HTML, and eventually the latest versions of HTML. 4.01, 4.02, and finally we'll talk about XHTML, which is a more sophisticated version of HTML. It's called extensible HTMLs, and we talk about the differences of HTML and XHTML, and that Visual Web Developer essentially develops all of our pages within the XHTML framework. And we'll talk about the document type definition, which defines the elements and attributes of the documents we can use and the ones that we cannot use. And finally, we will talk a little bit about design and formatting of our the display of our web pages and web documents through the use of CSS. And we will probably just brush up a little bit on the validating parsers that are programs that basically check whether an XHTML document is well-formed. And I'll talk about the documents being well-formed and how we can use this this information essentially to distinguish between different types of web documents and avoid making mistakes that would eventually show up on the website or web pages or web documents unprocessed. Okay, from last week, if you remember, we talked about web pages and how they are identified on the internet. And what we learned is that the web page is basically a document or a set of information that is put online in a physical location somewhere, and to identify this we use a unique address which is called URL, or Uniform Resource Locator. The URL for a web page, if you want to think about it, is like a telephone address, and it has different components, and analogous to the say, area code and the 3-digit and the 4-digit numbers for a specific phone number. And if you have a phone number with extensions, the extension number. So, and I'll discuss about these different components of the URL in a little while. So the two basic parts of a URL are essentially a protocol and basically the address for the URL. The protocol, in case of web pages, the HTTP protocol identifies the way that the browsers would have to access this web page or this document. And the second part of the IP address or the URL is essentially the domain name for the web server or the web server's internet protocol address or IP address, as I said. So, for example, if you look at HTTP colon / www.uhv.edu, the HTTP is the protocol, which is the protocol that the web browser knows how to access this information. Essentially, it tells the browser that it's a hypertext file, and the web address, which is uhv.edu. And if you want to access more information within that root web directory of UHV, you click on links, and then it takes you to the inner directories and inner files from the UHV website. Now, what is the HTTP? HTTP is called Hypertext Transfer Protocol, and the Hypertext Transfer Protocol, or HTTP, manages the hypertext links that you navigate on the web. Basically, when you click on a link that is an HTTP link, it tells the browser that this is a web document. It uses a markup language, a hypertext markup language, and the browser would parse this markup language and essentially visualizes all the data and puts the data on your screen. The essence is that the HTTP ensures that web browsers correctly process and display various types of information that are contained within the web text or the web pages. That could include graphics, audio, video, flash files, and of course the text and tables and everything that comes with an HTTP document, HTML document. If you look at the web pages, when you click, and I'll show you a quick example of this. When you look at the web pages, you'll see that the first part of the web page is basically contained within the name of the protocol that you're using, and then a colon, and then 2 forward slashes. That is the protocol component of your website. After the 2 forward slashes, you will see a set of words or names that are separated by a set of dots. For example, www.uhv.edu. This portion is called the host name. The host refers to a computer that you access remotely to basically retrieve the URL or the web document from. That is the host. And in the case of a URL, usually the host portion usually contains the words the letters www, that stands for World Wide Web, and then the domain name of the computer, followed by, or the network, followed by the domain identifier. The domain name is a unique address that is used to identify the computer. Usually this would be a web server in the case of the HTTP protocol and file transfers. And this is a location or a name that is given to this particular server, unique to this server, and is on the internet. The domain name basically has 2 parts. The first part, as I said, is the name of the computer, and they're separated by a period. And it's usually made by the web administrators to represent the name of an organization, the name of a person, and so on. And the next part is the domain identifier. The last part of the domain name is the domain identifier. The identifier essentially tells you what kind of organization or website you will be accessing. These are like .edu, .com, .net, .org, .gov.mil, and so on and so forth. In case of international addresses, they would be the abbreviation of the name of the country. For example, if the website is hosted in the Netherlands and you want to access it, sometimes these websites, in order to tell you that these are based in an international or another country, it would follow the .nl for Netherlands or .uk for the United Kingdom. The extension, or essentially the identifier, as I said, are like .edu for educational, uhv.edu, .com for commercial, for example, amazon.com, .gov for governmental organizations such as dhs.gov, and so on and so forth. And this essentially gives you a sort of easy to understand information about where the website is located at. But keep in mind that these words, essentially www, that identifies the type of the web document, which is a World Wide Web document, or essentially a hypertext markup document, followed by the host name, which is the name, followed by a dot, followed by edu, com, or whatever identifier you have. These are for us humans to understand and to be able to access them easily. All of these information are contained within a set of numbers that are called the IP numbers, or the Internet Protocol numbers of the host. So, for example, if you look at what www.uhv.edu refers to, it will be 4 3-digit letters that are separated by dots. It could be, say, 192.2.37.60. And each of these informations refer to the different levels of the Internet Protocol address of the computer or the resource that you're trying to access, or the host that you are trying to access. In order to make it easier for us humans to connect to our web resources, there are domain name servers on the internet that when you go on a browser and you type www.uhv.edu, this information will be transferred to the domain name server. The domain name server looks at this name, the domain name uhv.edu, and of course keeps in mind that www is the World Wide Web resources that you're trying to access, and then maps it from that domain name server with the actual physical IP address of the server. It could be, as I said, 192.67.37.60. That would be, for example, my server on the UHV network. And then you would access the information and retrieve the information for me. If you notice, when you click on, say, http://www.uhv.edu, that takes you to the main website, or the default page of the website. Sometimes you may need to access another link within that website, or another link within that server. So you could use directory and file names, which are actually physical directories and file names on the hard drives of the server, which actually hosts that information. If you don't use that, the directory or the specific file name within a directory, the web browser automatically look for two files, default.html or index.html. If you don't specifically ask for the files. And in that case, it would automatically upload the default.html, which would be the home of the website. Usually web developers put the home of their websites within either index.html or default.html. And I'll show you soon how it looks like. So just let's look at this this particular address on the web. What the person wanted to access was the index page, or the default page of Google. The default page is put in the, or the index page that the person wanted to access in this case was placed in the directory help within the root of the Google website on the web server, on the Google web server. So we would type http://, that's the protocol of our website, or web server that or the web document that says that we need to use the HTTP protocol, hypertext transfer protocol. That indicates to the browser that the file we're trying to access is an HTML or variations of HTML, uses the markup language, and we need to parse it according to the correct parser. Then we put the www to refer to the page that is a World Wide Web page, and then we put the server name or the host name. The host name is google.com. Google tells me that it is Google's website, and .com tells me that this is a type of commercial website. And then I want to access a file within the help directory as opposed to the root or the main directory of this website. So I put /help, and then I put / the name of the file, index.html. If I had another file, say ali.html, I could type that and it would be retrieved. If I don't put the index.html, my web browser still automatically looks for either index or default. If these files exist, it would show them. If they don't, it wouldn't show them on my web browser, and it would probably give me a 404 error. That is essentially an error indicating that such file does not exist within the directory on the web site that I was trying to access. Although HTTP is probably the most widely used protocol on the internet by average users, there are many more protocols on the internet, such as FTP, File Transfer Protocol. And there are some FTP servers, as opposed to web servers, that include set of files that are to be shared, or people could access them and share them. And that protocol is specifically designed, as opposed to HTML that is or HTTP that is designed to read markup languages and visualize them and show them on the web browsers. The FTP is designed for transferring files efficiently, packaging files efficiently, and sending them over the peer-to-peer or any other types of networks. And these networks basically are a part of a much bigger communication protocol that is called Transmission Control / Internet Protocol, or TCP/IP. And if you notice from your Windows, if you're using Windows or any other types of machines, if you have experience with setting up your internet access, you would see that you would require to set up your network using a TCP/IP setup page on the settings of your system, and it requires you to have the IP addresses for your computer, the IP addresses for your hosts, for your domain name servers, and so on. And this is a 7-layer protocol that starts from the physical layer to all the way to the application layer, and it controls. It's basically a large collection of communication protocols that controls and governs the access of data over the internet. And essentially HTTP is a part of this component. Another protocol which is very similar to HTTP is Hypertext Transfer Protocol Secure, or HTTPS, and it would provide you secure access to websites and web informations that requires encoding and encryption of your data when you are passing information back and forth from the client machines or to the web servers, such as your bank accounts, your usernames and passwords for financial institutions, and so on. And that protocol is basically similar to HTTP. You just open your browser, you put HTTPS : // and then the name of your web host and the files that you need and you want to try to access. All right. Now that we have talked about the internet and the World Wide Web, I talked a little bit about web pages, web servers, IP addresses, locations, physical and virtual locations of web pages on a website. Let's talk about the different aspects of web page creation. There are 3 different and distinct kind of applications in creating websites and web pages, and I'll talk about them a little bit, and I'll tell you what aspects of these techniques we will be studying more intensely in this course. Let's start with web page design. The web page design or web design basically talks about the visual design and creation of a web page. If you look at any web page on the internet, from commercial web pages to personal web pages to blogs, you will see that the designs are vastly different, and making a very good website starts with designing a very good visual representation of your website to make it attractive for the first-time users, and even more attractive to the ones who are recurring users or repeating customers if it's a commercial website. And this aspect of web page creation falls under the basically artistic development of a website, and it essentially talks about the visual representation of your web pages, and it could basically play a life and death role for the essentially the website to becoming popular. Throughout this course, we will unconsciously, and I would like to repeat the word unconsciously, that we will design our web pages. But the focus of this course is not design or graphical design of your websites or web pages. But throughout the examples and the processes that we perform during this semester in this course, we will try to design visually pleasing websites and put our data and information in a consistent format. But we will not go into the details of what makes a website really look great and what makes it not so user-friendly for the users to want to come back and visit our websites. The second aspect of web creation is web page authoring or web authoring. The web authoring refers to creating the assembly of tags and attributes and the data that eventually make up the web page. Now, the difference between the web authoring and web design is very, very small, essentially, but it actually requires a little bit more thought in terms of finding that specific difference. In web design, essentially you're talking about visual and graphical design of or visual and graphical design aspects of creating your web pages, whereas in terms of web authoring, we are talking about physical task of putting the web page together, the tags, the attributes. And when we study about HTML, or if you have learned a little bit about HTML, you will see that there are different tags in a markup language that you would have to be aware of and know what their parameters and attributes are in order to create a website that works consistently and efficiently. So in web authoring, we are actually creating the web pages, but that is not the software development for a web application or a website or a web page application. It's just the creation of your markup languages. The third aspect of web creation is the web development or web programming, which is the majority of this course is about, and that refers to creating and designing software applications for a website. For example, if your website is accessing the database and manipulating a database behind the scene, essentially, you as a web programmer or a web developer, you are responsible for creating and writing the data and the programs and the applications that work behind the scene of your HTML file or your website file or your web document that take user inputs and then connect to for example, the database, and the programs that you write to manipulate the database according to the user inputs. They are not visible and to the web user who's working with your website, but rather they are working behind the scene in order to create the data that the user is expecting. So if you think about, for example, a process such as, and I will talk about it a little bit later, such as JavaScript scripting, which it basically lies in under the field of web page authoring. Some of this programming that you will do in JavaScripting lies under web development, and especially when you are talking about sending and receiving data from a web server. Those kind of programs essentially will not be presented to the user or to the application user, but rather they work under the skin of your web page application or your website application. So just I want you to keep in mind that we have these three different aspects of creating a website. We will give a lot of consideration to web programming and web development through active server pages, JavaScript, and that sort of processes. We will require web authoring abilities, essentially, to be able to not only program the building blocks and structures of our website, but also to be able to understand and essentially compile our own websites and web applications to have a little bit of insight in the future as to how this website will look like. And finally, we will have to be unconsciously aware of web design and creating websites that are visually pleasing and graphically interesting for the users. So if we have a form, we just don't want to bunch up all of these different parts of a form, like labels, tags, and text boxes, check boxes, and buttons. We want to put them together in such a way that they are easy to use and they're also visually pleasing to the users. All right, now that we know about the three different aspects of web page creation, or essentially web development, if you want to think about it in a general sense of the word, one should consider how a successful web development might occur. In order to understand or basically to be able to successfully develop web applications, we need to understand the basics of client-server architecture. Client-server architecture is the main architecture that the networks are built on, and essentially any kind of application that requires remote access to a processing center follows some sort of client-server architecture. You can define the terms clients and servers in many different ways, but in a traditional client-server architecture, the server is usually some sort of database, and the clients would request some information or data from this database, and then the database system serves the data to the clients. Once a client requests information from the server looks at the information that is requested and fulfills this request by managing or serving the requested information to the client. The system that's based on this one server, or essentially client-server architecture, is usually also called a two-tier system. The primary, or one of the primary roles of a client or the front end of this two-tier system is to create a presentation interface to the user. And the user interface that the client server presents gathers information from the user, packages this information, submits this in a form of request to a server, or also the back end of this architecture. Once the server processes this data or information and creates the results or queries and sends them back to the client or the front end, then the front end receives this data, formats them, and presents them to the user, or essentially visually represents the data on the user or the client machine. The main responsibility that the server has usually is to store the data and manage this stored data. Most of the databases perform these tasks on the server side. In a client-server system, if you have a heavy processing such as calculations and heavy management of the data, usually these processes take place on the server side, and from the beginning of the networking technology, the clients usually were really just input-output devices. They had a keyboard and just a monitor, and they were only capable of gathering information as keystrokes from the user and just showing information as text on their monitors. Therefore, most of this processing in any form, an application in client-server architecture would happen on the server side. So the users would just send the queries as texts given as an input from the keyboard to the server. The server would process the information and the requests, and then would send the request as a text file back to the clients, and they would show the client would show the information, requested information, to the users. As the technology started growing, desktop computers became more and more powerful. And at that point, some of the client-server applications relied on the power or the processing power of client sides, and started making keeping some of the processes basically on the client side. And this way, the clients would have essentially an efficient way to perform some of the processes and calculations to create from the raw request a little bit of more of a mid-level request or query to the servers, and the servers would be able to process more and more requests at the same time, because their processing power or the processing power that was needed from the server side was decreased. However, there are some processes that are still required to basically be kept on the server side, especially in some specific applications that you require some sort of secure processing happening on the server side, so no client could bypass your code or your program or application and harm the process. So if you want to think about how this client-server computing in a typical application works, is consider that the client creates some request from a database and sends the request to the server, and the database is located on the server. The server looks into the database and locates the records that the client requested, performs some sort of processing on them. Let's assume that the client requested the total amount due for his or her registration according to the number of courses that he or she registered, and then the server locates those courses, the number of credits, and the fee for each credit, calculates the multiplications, and send the processes the information back to the client, and the client would show this information to the user. However, as I said, some of the processes can also occur and happen to on the client machine. For example, if a client had a more complicated request and they wanted to build a little bit more complicated requests, they could perform this process on the client machine and then send this request to the server. Also, when the requests are answered from the server and sent back to the client machine requires to perform a little bit of processing, parsing the return data and processing the visual representation of the data according to even if it's sent through a markup language, and then presenting the systems to or the information back to the user. This picture shows you how a typical client-server two-tier machine architecture rather works. As you can see, the user sends the request, and then the server processes the request, sends the response back, and the client would show this processed information. As I said, web is built on two-tier client-server architecture. And in this architecture, your web browser on your machine is basically the client, when you type the web address for a web page, when you have the web page loaded and you type in some information, you click a button to send the information, or when you click on a link in a website, in a web page, your web browser, the client, requests the documentation or web documents or the process information from a server which is called the web server. The web server essentially is a library or a storage for web pages. After the web server locates the page that you requested or calculated and performed the processing that you requested, it would send the requested documents or the requested information within a web document back to the browser or back to the web browser. At this time, the web browser, as a client user interface, is responsible for parsing the information, formatting the document, and presenting the document in a visual manner to the user. And this request from the web browser to the web server of some sort of documentation, and the response that the web server gives to the web browser happens through a protocol that we saw earlier, and the protocol is HTTP, or Hypertext Transfer Protocol. For example, if a web browser requests www.uhv.edu, or in long http://www.uhv.edu, this information or request is performed and sent to the server with the HTTP protocol, and the URL that you sent includes the HTTP protocol. The web server at this point understands that the web browser or the client is requesting a hypertext information or document. It would locate the hypertext document and it would send the hypertext document and as a response header and the HTML or HTML document back to the browser, to the web browser or the client, which is essentially the web page for www.uhv.edu. At that point, your web browser parses the page, takes out the markup language, markups from the language or the file, the HTML or the XHTML file, and takes the markups out and presents this different tags and components of the page as it should be presented within an HTML or an XHTML web document. Now, the example that we saw earlier was just a simple request for a web document, or maybe a small amount of processing that would happen between the client and the server. After we start adding more and more capabilities to our client-server architecture, or essentially adding databases to our client-server architecture and other types of applications on the web server, the client-server architecture that we have already, it basically starts evolving into a three-tier client architecture. And a three-tier client architecture, which also we call it a multi-tier client architecture, or multi-tier client-server system, we have three distinct pieces: the client tier, the processing tier, and the data storage tier. In the client tier, or the user interface tier, we have, for example, a web browser, or we have a client software or a client application that is responsible for creating the request from the user and submitting it to the server side, and also presenting the data to the user when the response is ready. But on the other hand, the database portion of the two-tier client-server system that we have already now, because it's now a lot larger and a lot more dedicated, we can split this tier, or the server tier, into two processing tiers, or essentially a processing tier and a data storage tier. The processing tier, or the middle tier, handles the interactions between your client side, which is the web browser, and the server side, which is your database, or essentially your storage side, which is your database or data storage tier. Sometimes we can call this this middle tier as a bridge or a processing bridge. When the client tier makes a request of a database on a web server, for example, you go in your UHV account and you log into your student account and would like to see what courses you are registered or what's your grade for a specific course. On your web browser, which is the client, you create the query or the request, and when you send this query to the server side, the request is performed or essentially requires some information from the database. The processing tier takes your request, breaks it down, and creates necessary processing or calculations on the request, and then sends this information into the storage unit or the data storage tier. Once your data storage or the data is located within the data storage, the processing tier is also responsible for creating the information that you requested through your client tier or your web browser, and sends this information back to your client tier or the web browser. But however, you should keep in mind that your web browser or your client tier is also responsible for performing some of this processing, and this processing could be as simple as rendering your web page document, or as complicated as combining multiple web pages and basically presenting more informative data to you through its processing powers. And this figure essentially breaks down the information or breaks down the multi-tier client-server system. And as you can see, again, just brief mention, you perform a request from your client tier, and your client tier acts as an interface. It creates the data that you want or request, sends the query to the server side, which is two distinct tiers now, a processing tier and a data storage tier. They can be the same computer though, but for massive databases, such as the university's database, your processing servers are usually different than your data storage servers. They're stored on different machines. They are performed on different machines. Also your client tier is responsible for showing the data to you, presenting the pictures, presenting all the colors, and the data that you requested. The processing tier handles the interaction between the web browser and the data storage tiers, performs meaningful requests to the data storage tier, and the data storage tier retrieves the data, actually stores the data, and you can retrieve the information you're requesting from this tier, passing it through the processing tier back to the client. All right, now we know about the architecture of the web and the client-server architecture, especially a three-tier client-server architecture, which contains, which is consisted of client tier, processing tier, and data storage tier. As if you remember from last week and earlier this week, in this lecture, HTML is a language that is developed in order to render web pages in a browser, and it was not developed to control the appearance of the web pages on the browser. Therefore, the first HTML web pages were static. That means that when you loaded your web page, everything was static and it wouldn't change. This would limit the user's interaction and interface with the web server, such as typing login information and validating this information, or validating form informations and things like that, and also even controlling the appearance of the web page. However, as the web pages started growing beyond the small academic and scientific community, where people just needed to exchange information in a static way, people started to realizing that the web could be a lot more interactive and much better visually represented and designed in order to create more useful web pages. And when the commercial applications started to becoming popular and growing, the demand for this interactivity basically started growing beyond the basic HTML and XHTML applications, which were basically static documents. When you and the way that what I mean by a static web page in HTML or XHTML is essentially like a Word document. Once you type the Word document, then all you can do is either print it or just watch it on the screen, and by itself it wouldn't control its appearance. It cannot, for example, every other hour change the font colors and numbers of, say, odd lines or even paragraphs. So in order to basically make more flexible applications, and the applications that would be more visually appealing and also interactive applications, Netscape developed JavaScript. And what essentially JavaScript is it's a client-side scripting language that allows the web page authors to develop interactive web pages and websites. When you think of a client-side scripting, you should think of it as a scripting language that runs on your local browser, or essentially on your client tier, instead of a web server or your processing tier. The JavaScript basically was developed by Netscape in order to be used in Navigator web browser, but as the need grow for client-side scripting and more interactive website development, more browsers started incorporating the JavaScripting engine into their browsers, such as Firefox and Internet Explorer. There's one thing about JavaScript and Java. JavaScript is a simple scripting language that essentially creates fairly simple codes or scripts in order to run the appearance of your web pages on the client machine or on the client side. However, Java is a full-fledged object-oriented, complicated, high-level programming language, and basically it's entirely different than JavaScript. And you can use Java language or Java programs to control web pages. The difference is that you cannot use them as an internal program within your web application. You have to have Java programs or external programs, and they execute independently of your browser, but they can communicate and interact with your web browsers. In contrast, JavaScript programs always run within your web browser and control your browser. The part of the browser that executes the scripting languages, such as JavaScript, or scripting codes, is called your browser scripting engine. This engine is just a simple interpreter. Probably I shouldn't have said simple, but it's one kind of interpreter, and it generally runs your programs in a consecutive manner, line by line, interprets the information and the programs, and executes the piece of code. When you load a scripting engine onto a web page, it starts interpreting your programs that are written in that scripting language, like a JavaScript. The web browsers that contain the scripting engine are called a scripting host. Firefox and Internet Explorer are the two examples of scripting hosts that are capable of running JavaScript programs. Although you can consider JavaScript as a programming language, it is not an independent programming language, meaning that you cannot write JavaScript programs independently of your web browser. Therefore, this mechanism or this language becomes a very critical part of your web page authoring. And I would like to emphasize the web page authoring as opposed to web page development, which I will be talking about when we're talking about server-side scripting. That is, in your JavaScript programs are an important component of your interactive and dynamic web pages that you create, but they are essentially creating documents and programs that control the appearance of your web pages and give some levels of interactivity to your web pages. They are not programs or applications that perform any critical processing of the data from, let's say, a database or a data storage layer within your server. So we can classify them as web development tools. What does JavaScript let us do? It accounts for a lot of dynamic capabilities and interactive capabilities on the web pages. It allows that it basically changes the static web pages into applications that are more interactive, like games and calculators. It also changes the contents of the web page after the browser renders it. So if you needed to change some content on your web browser, for example, if you are trying to show the time and date, you could perform that within your JavaScripts. You can include more visual capabilities such as animations and images, or changing images to your web pages, and also you can control your browser or your web browser window itself. So these are the capabilities that your JavaScript allows you to do. However, be warned that there are security reasons that limit the client-side scripting or client-side JavaScript programming languages. One of the limitations is that your JavaScript cannot be used, or your JavaScript programming language cannot be used outside of your web browser. This is due to security reasons, as I said. If you allow the JavaScript, if the JavaScript programs were allowed to run outside of your own web browser, they could have been used in order to steal information such as email addresses and credit card informations and that kind of stuff that are not within your web browser itself, but they are stored actually remotely on other hosting parties. Also, for the same reason, your JavaScript programs do not allow you to manipulate files, and that's obvious because we do not want a JavaScript program to be able to bypass all of the security protocols of the client machine and access the files by just simply opening a web page. Also, your JavaScript programs cannot connect to a network and cannot access any databases, and this also is useful in order to prevent the private networks to become infiltrated by just simply somebody opening a web page and wreaking havoc over the private information that is stored within the network, because the client servers was able to connect to the database or to the network itself. Another useful limitations that are placed on JavaScript is that they cannot run system commands or execute programs on clients. For example, if you and essentially the only processing that your JavaScripts can do, which are you could consider that outside of your web browser, is only accessing, reading, and writing cookies. And cookies are essentially some information that are gathered from the accessing some specific part of your web application that are unique to you, and you need to have access to them in order to facilitate your internet application. And they are stored within a small string of numbers. Of course, they are coded, and then when a JavaScript reads them, it will be able to basically break the information apart and access to the data that you give the browser access to. So although the JavaScripts can do this kind of processing or accessing of cookies, usually web browsers are very strict in terms of governing cookies and do not allow any access to cookies from outside the domain that these cookies are created. So if you're created your or the cookies are created within a particular domain, like for example from specific intranet or a specific LAN, access from outside of this domain is not really granted to the cookies. Another byproduct of this security is that it would not allow JavaScripts to interact directly with web browsers that are operating at the processing tier, because those processing are not applied within the web browser's domain, which is your client, but rather they're on the server side. So JavaScript will not be able to directly access, or your web servers or your web programs are not directly allowed to access web servers. So how to deal with this limitation, especially the last one, that we need to have access on the server side? That is the part that is that server-side scripting languages such as ASP.NET are responsible for. Server-side scripting is a technology that processes a request for a web page by executing the script on a server. One of the primary reasons for using a server-side scripting language is to develop interactive websites that can communicate with databases. As I said, databases are stored on the data storage layer or data storage tier of the system, and even though we may have a web browser or a client side that is capable of client-side scripting, because of the limitations that client-side scripting languages have in order to access something that's outside of their domain, which is the database on the server side, which is basically beyond the processing tier. We need server-side processing to be able to perform this kind of processes within the server. The server-side scripts essentially work in the processing tier of the server, not the data storage tier. But they facilitate and handle the communications between the client tier programs and or the client tier applications and the data storage application. At the processing tier, your server-side scripts usually prepare and process the data in some way before submitting it to the data storage unit. And the data storage unit then retrieves the data and sends them back to the client side. Let me just give you a couple of examples of some of the server-side programming capabilities that we see on the web. Shopping carts, for example, are a server-side process because all of the information that you have in a internet shopping mall is stored on the server, and before you finish up and you pay out all your amounts due and everything that you have, all these informations are stored on the web server and they are processed on the web server. Once everything is done and your transaction is completed and committed, the money is transferred virtually from your bank account to the shopping center's account. Then you will receive the confirmations for your purchase, and your purchase will be shipped to you. Search engines is are another example of your server-side scripting. Mailing lists and message boards, web-based email systems, or another server-side scripting. Your UHV mails are stored on the server side on the UHV mail servers, and your client browser, which is your mail application, such as Outlook, will have only access to the data on the server through server-side processes. Authentication and security mechanisms when you log into a website, weblogs or blogs, games and entertainments are another examples of server-side processing. For example, think of game applications. In a massively multiplayer game, or MMO, or MMPs, rather, the information about each of the players is stored within their client, but their interactions and the gameplay of the the game essentially happens on the server side and are processed on the server side as well. Before I go on to more details about your the scripting language that we will be using for our server-side processing, let me just give you a distinction between client-side processing and language and rather scripting languages and a server side. You see, unlike JavaScript that was able to manipulate your web browser, server-side scripts can't access or manipulate your web browser. That is, all of the processing that are occurring on the server through your server-side processes or server-side scripting languages happen within the server. And the only thing that your server will be able to emit out or send out of the web server to your client web browser is essentially an HTML or an XHTML file. So it performs all of the processes on the server, or it performs all of the web server or server-side processes within the server itself. Once it has all the information completely processed, for example, you asked for the total amount due after you purchased some value, some items from an internet shopping system. It would perform the calculations. It would perform the total amounts. If you have coupons, it would apply the coupons and all that kind of things within the server. And all that it sends back to you is an HTML that contains completely static text of your or essentially the confirmation web page, which looks like the items that you purchased, number of each of those items, how many you purchased of each, and the total amount due. And all this information are static numbers, static images, static text. That is the HTML document that the server creates and sends back to your browser, and your browser would show that to you. Now, if you had on your browser client-side scripting languages, those would still take care of manipulating your the web document on your client side. But all of the processing on the server or all of the server-side scripting will be done, and when you retrieve the information and you have it on your client side, the programs are going to be gone. All you see is going to be the result of this. This may sound confusing now, but I would like to tell you that when we perform some of these ASP programs, I would occasionally click on the source code of our ASP programs or ASP web pages, and I will show you what I mean. That, for example, if I have a server-side program that is responsible for showing date and time, the program itself runs on the server and has the date and time which is changing, but when I click to request the date and time, this request goes to the server. The server-side program calculates the date and time, creates the date and time in a string, and puts it in an HTML file and sends it back to me. Now, when I have it on my browser, it will not change as the time goes by until I request again for a new updated date and time. That is that the date and time that is calculated from the server side is sent back to my browser as a static text, as opposed to a date and time that is changing in real time, right? So this way, the web page that will be sent to me is going to be just a simple HTML and no server-side programming on it. If I want to have a date and time that is changing all the time, I should use a client-side program that will manipulate the date and time of my client machine and puts it on my website or the web page that I requested. So if you want to think about this process in just a nutshell, here's how it works. Your client requests a PHP script, for example, or any kind of server-side programming, an ASP script, to the web server. The web server or the scripting engine within the web server looks at the code, interprets the code, and executes the line of the code on the server, and creates and translates it and the information that is requested. In the previous example I gave you as the date and time on the server, and puts it in an HTML or an XHTML file, and then returns the HTML or XHTML file back to the web browser, and the web browser shows that that file. Now, the server-side scripting language that we will be using is called ASP.NET. And ASP.NET is short for Active Server Pages.NET. It's a server-side scripting technology that will be shipped with the Visual Web Developer that we will be downloading and installing from Microsoft. And there are two languages that we could use in order to write server-side programs, Visual C# or Visual Basic. The book that I recommended for the ASP.NET 4.0 basically uses both of these languages. So any code that is developed within that book is in both Visual Basic and Visual C#, and that makes it easier on you to use your language of choice. I don't know if you prefer Visual Basic or Visual C#, but this book will allow you to write programs and server-side programs with either one of these two languages. I will mostly use C#, and so I'm more comfortable with C#, of course, because I studied C++ programming language more than Visual Basic, and I feel more comfortable with it. Visual C# programming language is an object-oriented programming language that is built on C++. However, it's much simpler to handle than C++ because C++ is a full programming language, and it's one of the most widely used programming languages that exists today. C# makes it a little bit easier to master, and also it's basically, you can consider the C# as a more friendly version of C++. The notion of object-oriented programming, which we will be discussing a lot more when we start studying the C# programming, or essentially our Internet Active Server Pages programming, is the fact that you can create reusable objects with classes that can inherit properties and methods from their parent classes. They encapsulate the data and the properties and the attributes of your classes within the objects that are instantiated from. And they're also reusable, and you can use these developed objects within other programs. So for this reason, the object-oriented programming notion of C# allows us to create very, very dynamic and highly interactive web pages by simply creating objects that are required to perform the processings that we want to do. One important aspect of C# is that it is specifically designed to create web page applications that run under the .NET framework by Microsoft. Microsoft developed this .NET framework as a platform to create and develop web pages and Internet applications. So essentially, we need to use C# or Visual Basic to be able to access this .NET framework and work with it. And when we install the Microsoft Visual Web Developer on our system, it will automatically install the .NET framework and also SQL Server 2008. And this way we will have the building blocks of the application and the Internet programming powers that we require by installing the developer. Now, when should I use client-side or server-side? This is a very good question. It is a very important question in designing any kind of client-server system that runs efficiently. And we need to basically decide this before we start writing our scripts and programs. One of the reasons that this is important is that it can greatly affect the performance of your programs. For example, if you have client machines that are not capable of any kind of high-level processing, and you give a lot of high-level processing on your client machines, your internet applications are going to be either slow or not running at all. At the same time, it's important to keep the server side programmings as light as possible. Although the servers are much more dedicated, much more faster processors, when you have a website that has lots of users, if we have a lot of processing that are done, or I would have to say a lot of unnecessary processing that could be done on client machines and are done on our server machines, they would clog up the server and slow down the servers as the number of clients using the server increases, and this would severely affect our web application. In some applications, or some cases, the decision is in terms of which programming or which scripting we should do is fairly simple. For example, if we want to control the web browser, we have to use JavaScript or client-server scripting. As I said, if you want to show the date and time in real time of your local machine, because your server side does not have access to your client web browser, if you have it in the server side, it would only return your date and time of the server within a static XHTML or HTML code, and you will not be able to manipulate and control your web browser. So if you need to do that, you need to use client-side machines. If you want to use and access a database, you have to use a server-side script. As I said, JavaScript and client-side scriptings are basically denied access to the database or the server-side programs. There are some tasks that both languages can do, both server-side and client-side scriptings. For example, validating forms, manipulating cookies. All of the two language server-side and client-side languages and scripting technologies could perform these tasks, and that would be your own application, and you have to decide which programming you prefer. If you're validating some forms, for example, you want to register for a class, and you have a form that asks for your first name, last name, student ID, date of birth, and then the course number to access and register in the course. You can do and validate the information that are typed in the form on both client side and the server side, and I'll show you throughout this semester. But it would be important to decide which side you want to do. There are advantages and disadvantages of either keeping it on this client side or sending it on the server side. In general, the general rule of thumb is that we will allow the client to handle the user interface processing and any kind of light processing, such as data validation, if it's not a secure and very important data on the client side. But we have the web server use the server-side processing to perform intensive calculations and data storages. So it becomes even more important when you're dealing with client and servers over the web. If your client-server applications are within the same network, it might not be as important, but when you're performing this over the web, that means that your requests are going outside of your local network, processed somewhere else, and come back. You have to be even more considerate of this decision. When you have clients on a private network, it's not possible it is possible to know the processing powers of the computers within the network. Contact your administrator and take the list of all of the computers that are there and the browsers and the client-side applications that are installed, and you will have a kind of an idea as to how your clients would perceive your website. But when you're dealing with the web, that means that you're putting your application online for everybody to access. You will not be able to know what kind of computers your users are using, as simple as whether they're using Linux or Mac or Microsoft, or they're using Firefox or Internet Explorer or any kind of other essentially browsers, whether or not they have Java activated or ActiveX activated on their browsers and the clients. So it becomes more and more important to basically understand and design an application that the wider variety of browsers could support, or clients could support, or more and more audiences could have access and to our web site and web applications with the minimum inconvenience. And at the same time, keep intensive processing on the server so that they wouldn't have to deal with slow internet connections or slow processing powers, or even older computers and processing powers. And the trick again is that although instinctively would say, okay, let's put all the processing power on the server and let the users just display the information, that, as I said, it will not work, because again, if the number of clients to your web server or web application grows, the number of processing that's happening on your web server, of course, will grow, and at some point make your web server pretty slow. One reason for distributing processing among multiple clients is that it could essentially make the clients run more and more efficiently as the processing load from the servers become less. At the same time, your clients will be able to perform the processing that is given to them if the processing is reliable. And so for a web application, if we want to use essentially all of the powers and capabilities, we need to basically let a web program to run on the server, and also let the clients access through a web page that they could access it from their web browsers. The processes that are performed locally on the computers, they minimize the transfer time across the network, and also create faster applications. So if your client is using a very low bandwidth network, and all of your processes are happening on your server-side machine, there are a lot more information to be passed back and forth to your client, and since they have lower bandwidth connections, it makes them, or if the internet is busy, it makes the application even more slowly. So that's basically the nutshell about the main decision as to performing client-side processes or server-side scriptings. And essentially this would break down to, let's have the processes that majority of people can do on the client, and the ones that are safe to be performed on clients. Let's keep the secure processes and the more intensive processes on the server, and let's share the processing powers among clients and the servers in such a way that it would amount to an efficient and reasonable flow of data over the web. So to this point, I have pretty much covered an introduction and a history of the web and the protocols that we will be using. And I discussed the client-server architecture of the web. And I showed you about the processes that you will mostly work in the server side, and the processes that you will probably mostly develop and implement on the client side. What I would like to do at this point on this slide, I will close up this part of the lecture because I want to now show you how to install and work with the Microsoft Visual Web Developer in 2010 Express Edition. And I'll discuss about the Microsoft Visual Studio 2010 and its component, and how to get it and how to use it, or essentially how to get and install the Microsoft Visual Web Developer. So this will be the first part of the lecture for this week. There will be another video after this this video is finished. You can locate it from your learning module, and it will be called Lecture 2, Part 2, and it'll contain a tutorial about going online, getting the web developer, installing it, and installing Microsoft SQL Server. And with that, I will finish this week's lecture, and I will post you a quick homework and a quick programming assignment, which will be actually the two parts of the first homework. And within that assignment, you will need to create a website and basically submit your website to the assignment box, Dropbox, essentially. So with this, I will close this video, and I'll encourage you to locate the second part of the video lecture, which will show you about the installation of Microsoft Visual Web Developer, and basically the first introductory website that we will build. Okay, so thank you very much for listening to this lecture up to this point, and I will talk to you on the second lecture about Microsoft Visual Web Developer.